Hi, this is another video containing an example on finding the limit of a function. This is not a basic type of um, a problem, so I'll show you how to get the limit of this kind of function. Okay, so if you look at it, so if we substitute 0 to every h, then the value will become uh, 2 plus 0 to the negative 1 minus 2 to the negative 1 over 0, and this is equal to 2 to the negative 1 minus 2 to the negative 1 over 0. We know that 2 to the negative 1 is 1 half minus 1 half over 0, and this will result to 0 over 0. Again, whenever we get a 0 over 0, it means we need to simplify the function before we can get the limit of the function. So how do we simplify this? We have seen from the substitution technique that along the way we were able to simplify 2 to the negative 1 in terms of 1 half. So we will be doing the same when we still have the value or the variable h. So the actual solution, since it will not work for substitution method, we will be simplifying the function. So 2 plus h to the negative 1 is 1 over 2 plus h. 2 to the negative 1 is 1 half. And then we have over h. And most of the time, actually, if we have fractions involving or fractions in a function, the tendency is we combine the fractions. So this is still the limit as h approaches 0. If we will get the LCD of the two, you need to have 2 and 2 plus h. And 2 and 2 plus h divided by 2 plus h is 2. So times 1, this is 2, minus the LCD divided by 2, that will cancel the 2, and you will have 2 plus h multiplied to 1. And then this, everything over h. And we further simplify the function, so this is h approaches 0. This means 2 minus h. So all over the LCD, 2 times 2 plus h. Now in this step, I'll be simplifying over h. When we say divided by h, that is the same as times 1 over h. And then we continue to simplify the function. So 2 minus 2 is 0, then minus h, so negative h, over 2 times, by the way, this is just 2 plus h, so 2 plus h times 1 over h. And as you can see, the h and h can be cancelled, so this will be equal to limit as h approaches 0 of negative 1 over 2 times 2 plus h. And the moment you have obtained the simplified version of the function, you can now try the substitution again. So if we substitute 0 to h, then this will become negative 1, 2, and 2 plus 0 is equal to negative 1 over 2 times 2, which is equal to negative 1 over 4. Therefore, the limit of this function is equal to negative 1 over 4. Okay, so to summarize the solution, if there's a call for a function to be simplified, then you have to simplify the function. So there are many different types of functions. Sometimes you have to simplify by rationalizing the numerator or the denominator. But in this case, we have a negative exponent, so it calls for simplifying or taking away the negative exponent. And when we say taking away means you simplify, you rewrite it in terms of a positive exponent. So 2 plus h to the negative 1 is 1 over 2 plus h, and 2 to the negative 1 is 1 over 2. and then just simplify until you have obtained the simplified version or the simplest term. And once you have the simplest form, then you substitute the value of h, which is 0. And eventually, you will get the limit. Okay? In addition to that, we simplify the function whenever we obtain a 0 over 0 coming from the substitution method. So that's it.